In this video, I'm going to give a description of how we would encrypt a message. So some things we need to know. We're going to be using a scale factor, which we're going to call A. We may also then use a shift, which we're going to refer to as B. We are also going to be working in what we call modulo 26 because there are 26 letters in the alphabet. Remember that our goal is to take a simple message and encrypt it so that it would be difficult if it fell into the hands of the enemy, so to speak, for them to determine what was in our message. The first thing we're going to talk about then is our scale factor. In order to pick an appropriate scale factor, we first need to talk about how we would undo a scale factor. And in order to do that, we have to pick a number that will have an inverse. So how do we know if a number has an inverse? And what exactly does inverse mean? So within the real numbers, if we have an inverse, a multiplicative inverse, we would take A, we would multiply it by the reciprocal of A, and we would get 1. The same thing happens in our modulo groups. If I have a number and I multiply it by its inverse, I want to get something that's equivalent to 1 mod our group. In this case, remember, we're working in mod 26. So we need to make sure that whatever number we pick is relatively prime to 26. What this means is that the greatest common factor between the number we pick and 26 will have to be 1. So all the numbers that are possible when we talk about mod 26 are 0, 1, 2, on and on until we get to 25. The numbers then that will have inverses are 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, and 25. All of these numbers are relatively prime to 26. It's easy sometimes to think, oh, they're all odd. Well, they are, but that's because 26 is even. There are, however, odd numbers that are not in this list. Notice that the greatest common factor between 13 and 26 is actually 13. So 13 does not have an inverse. We don't want to use it as our scale factor because what happens is that 13 would then represent 13 different letters in the alphabet. You would either get 13 or 0 when you scaled everything. That would make it really difficult to encrypt. So this shows a list of all of our numbers and their inverses in mod 26. If you're unsure how we came to this, you might want to rewatch the video that is the first video in this series where we define these definitions. I'm going to choose 11 as our scale factor for this exercise, which means when we unencrypt the message, we will use 19. Okay, so we're going to encrypt the word whiskers. I'm going to let our scale factor be equal to 11, and I'm going to let our shift be equal to 10. Now, notice, 10 doesn't have an inverse. But that's okay because all we're doing is moving up and down the alphabet by 10 spaces. And we can undo that by then adding 10 or subtracting 10 as needed at the end. So only thing that needs to have an inverse is what we choose for A. This must have an inverse. The inverse of 10, again, will just be subtracting 10 at the end. So we don't need to worry about that one. So our first step is that we determine the number that represents each letter. I've done that here. Now remember that our A was 11 and our B was 10. So now what we're going to do is multiply each of these by our scale factor. So we're going to multiply it by A. And you can do this in your calculator. I'm going to go ahead and write everything in that they're going to be. So you'll notice that we use S twice in this. And as expected, we get the same things every time we have an S. So that kind of gives us a hint that we're probably on the right track. Okay, so we've used our scale factor of A. We've multiplied our numbers by 11. But now we're going to use that shift factor that I talked about. And we're just going to add 10 to everything. So this becomes 252, 87, 98, 208, 120, 54, 197, and 208. Now, we need to figure out how to convert these back to letters of our alphabet. And in order to do that, we're going to calculate each of these mod 26. Remember, mod 26 refers to the remainder. So if we take 252 mod 26, the other way that I can write this is 26 times 9 plus 18 equals 252. And our answer is then 18, which goes here. So this work down here, you'll need to show that you did, but it won't always appear in my charts. So let's look at 87. If we take 87 mod 26, we can write that as 26 times 3 plus 9 is equal to 87. So this answer is 9. Once you've calculated the modulo of 26 for each of these, you notice that all of our answers lie between 0 and 25, which means we can convert them back to letters. If we're going to send the encrypted message whiskers, where we used a scale factor of 11 and we used a shift of 10, we would send the message S, J, U, A, Q, C, P, A. That probably wouldn't mean anything if it was intercepted in the middle, but if you had the key, you would be able to unencrypt it. And that's what we'll start now. Let's say that you receive this gibberish message from your friend, and then you receive an envelope where they tell you that the scale factor they used was 11 and that their shift was 10. How are we going to unencrypt this message? This is the algorithm that we're going to use. We're going to convert our letters into numbers. We're going to subtract our shift since we added it when we encrypted it. We're going to multiply by our inverse, which is this. And then we're going to convert them to represent a letter using mod 26. So let's get started. So we've already converted them into letters, and now we're going to subtract 10 from everybody. This will give us where we started from when we added 10 the last time. It's okay if some of the numbers come out being negative. We'll deal with that in a few minutes. The next thing we need to do is multiply by the inverse. So we can see that the inverse of 11 is 19. So we're going to multiply everybody here by 19. Once we've multiplied everything by the inverse, now we need to convert everything into a number that we see in the alphabet list for us. So we're going to take everything mod 26. So when we take mod 26, some of these we know how to do because we've seen them before, but when we get to our ones that are negative, so negative 19 mod 26. Well, here's how I'm going to show you to do this. I'm going to take negative 19 and I'm going to add 26 to it. When I do that, I get positive 7. 7 is a number that's in my set from 0, 1, all the way to 25. So I'm going to stop, and that's the mod here. For 190, we're going to do this the normal way. We get 8. Now for negative 190, you probably don't want to sit here and add 26 over and over and over again. So why don't we think about it? I know that 26 goes into 190 7 point something times. 190 divided by 26 is going to give me 7.3 blah, blah, blah. So I'm going to round up to 8. So if I take 26 times 8, I get 208. I'm going to take negative 190. I'm going to add 208, which is the same, by the way, as adding 26 8 times. Remember, those are related. But when I add this, I get 18, which is, again, a positive number, and it's in this set here that I need it to be in. And that's our remainder when we talk about modulo. For 152, we're going to do something similar. So negative 152 mod 26. If you divide 152 by 26, you see that it goes in a little more than 5 times. So I'm going to add 26 to negative 152 6 times, but I'm just going to multiply it out so that I can see what it is. I get 156. So 156 minus 152 is going to give me 4. That is my remainder when I do modulo 26. We've now unencrypted our message to the point that we have all numbers that will represent letters within our alphabet. We can go back to our chart and determine that our message was whiskers. So I have one last thing for you. This is the message that you received from your friend, ZCWQM. Your friend tells you that they used a scale factor of 9 and that they used a shift of 4. I want you to decode this message and bring it to class with your work on Monday, April 11th, and you can get +2 bonus points on your exam. You must have your work, otherwise you won't get credit.